here is heterogeneous operating systems. This has been a really exciting feature to watch emerge. It's been frustrating because this is both source. This is one of these things where we've been wanting to do this for quite a while. It definitely is part of the, you must get other components working before you can get this fully in. If you pay very careful attention, we've been inching towards this feature for quite a while. And I want to frame it a little bit. So the multi-OS support, more affectionately called heterogeneous operating systems, means that Crowbar can do several things. First, that Crowbar does not require all of the nodes in a system to be the same operating system. So in a deployment to be the same operating system. So just enabling Crowbar to handle SUSE, Canonical, Red Hat, Windows, whatever, in the environment and still have bar clamps work is a significant goal. Just having different versions of the same operating system is a significant goal. I'm already seeing OpenStack development on the latest version of Ubuntu, and we know that it takes a certain amount of time and effort to bring out new operating systems. So part of our goal here is not just to enable different operating systems to coexist, but to enable different versions of the same operating system to coexist, because that's an important part of migration and upgrade stories. The other thing that's really significant for us with this is that we want to be able to bring up operating systems and infrastructure that doesn't have all of the agents, all of the capabilities of the systems that we have. So if we wanted to bring up a switch and bootstrap a switch, or bootstrap a locked hypervisor that we couldn't put an agent on, or literally add any type of operating system or environment that we didn't yet have full Crowbar integration for, this is going to make that first step easier. We hear a lot about this from the field. The requirement that Crowbar only has one operating system has been a frustration on our team, with our community and partners.
You put the attribute-driven recipe information in multi-OS.
Can you fix that behind?
Maybe.
Okay. Sorry. That would be confusing. I thought I got these right. It's in that Word document that I distributed.
Okay. I'll get it.
Thanks. So we'll pull in the correct information into the thing. I'm going to shut down some of these LinkedIn, these synced in. I suspect it's starting to choke on the number of components or windows that I have open. Good. Okay. All right. Sorry about this while we get these pieces working out. And so if you look back through some of the discussions that we've had around Crowbar, we've talked about external entities. One of the aspects of external entities is that we have a system that we can't control and manage. So there are data model implications for this also that mean that we have to be able to model objects that we don't take through the normal discovery. One of the other things that we've heard pretty clearly that people want to be able to do is be able to have their own jumpstart, bootstrap, whatever word you want to use for the initial Pixie discovery and deployment images. And so this effectively would allow you to do that. It would allow you to bring in a new Pixie image and get that running and make that part of the system. I'll do it while you talk, Greg. Don't worry about it. I think I've laid out this problem in probably more detail than people needed.
Yeah, so let's see. How are we looking at doing this? So initially we thought a way to do this, and if you've been watching the trees and the provisioner, you've seen it slowly morph into the ability of almost taking just about any ISO and serving that out. The goal would be that, and so that was the first pass of kind of this effort. it turns out that with some of the online work and some of the other stuff, it seems like we can almost get it to where we could serve anything and move forward. There's two side effects of being able to serve just about anything. One is, do you want that node actually managed in Crowbar, or do you just want to be able to install it? So part of this work will also include not just being able to deploy an OS, but also around dealing with, what does this node look like? Is this node going to be managed after the install by Crowbar? Can we put the Crowbar functions in so that it could be deployed and then joined to Crowbar? All those things are kind of comprehended by this larger story. So the first things you'll see are changes to online mode and the install path to say, okay, if you give us this directory, we'll install it. We'll add UI features to let you select what OS to put on the node, but it'll still mostly go through a Crowbar path. The next step will be around, once it's installed, do I keep it as a Crowbar node? Does it become manageable? Does it not? Those kind of things, if you're familiar with what our operations say with regard to things like, you've seen the Crowbar join scripts that are what we actually run to add the node to Crowbar after the initial installation. Whether those exist, how you add those kind of things will be wrapped around a set of functions or features, design features of adding nodes to Crowbar after they're installed. And so like, if you think about it, we're kind of not separating because they were already separated, but enabling kind of whatever you want to install and then how you want to actually manage it once it's installed. So so like in the use case, it says maybe we want to be able to deploy a firewall, right? At the end, we may not end up
I'm not going to be able to get back to it until people drop off of that node. I'll show you the text that's in the document. That'll let you talk.
Okay. So for example, deploying a sonic firewall, the first pass may not actually be something we manage by hand, but at least you can get it installed and into your environment. The next set of steps would be around adding it as a node that Crowbar manages, potentially adding it, depending on what it is, adding system points to manage it either through code on the firewall itself, in the case of like a Linux-based firewall running on FreeBSD or something like that, or in the case of like a third-party firewall, you could envision a piece of software running on a node somewhere that lets you drive that configuration external once it's installed. So those things become options down the road. The main thing to realize is a lot of this is trying to get just basic installation of other systems in place. Ideally, using our online and current provisioner changes. We realize that the next step of this feature is adding these arbitrarily installed nodes into Crowbar, right? Now, that second feature, right, we often call that, what did I call it? I don't remember. Adding nodes to Crowbar?
There's like an
yeah.
It's unmanaged.
The interesting part about that feature is useful outside of the heterogeneous OS story to let you be able to do things like, once we have a way to let or define these Crowbar join sets of functions, allows you a way to extend those in such as adding VMs that are running, for example, in an OpenStack deployment into Crowbar to be managed so that you could deploy other solutions on top of those VMs from Crowbar so that you could see them as nodes and other things like that. So that feature, it kind of goes in hand with this. Some will do automatically, it's just we want to support that OS. Others it'll be like, well, you can at least install it, but others may choose to add that feature as a secondary kind of item. We didn't call that as a first-class feature because we think it's interesting. So it allows us, as Christoph is pointing out, to decouple OS installation from joining into Crowbar, and we think those are valid. From Crowbar's perspective, the first, or what we felt from a requirements perspective, was the first is to get the ability to install some of these secondary OSs out there, and then to add the solutions. I know, depending on who you are in your use case, that ordering can vary, and we understand. But right now, we think this is our first pass. So, anyway.
In some ways, this would enable you to use Crowbar as a substitute for a bare metal installer and leave it at that, which is fine. We feel like Crowbar has value. Its value is in other places, but yet we also have heard feedback that sometimes people just want to get that done, get that work done, with the potential for BIOS and RAID and IPMI configurations and discovery and things like that.
Yeah. So that's the big driver, is the pre-work that Crowbar can do on the nodes before the OS install occurs. So like setting up the IPMI access is kind of useful.
Another use case that we've been asked about, and I've been always excited to have, but not able to do yet, was effectively a diagnostic image, so that you could have systems boot into a diagnostic image, run a full system diagnostic. When we present Crowbar to our internal support desk,
Victor's going to type on me.
We get a lot of enthusiasm about that use case.
Yeah, in fact, our tree already has an example of that. It's called OMSA hammer. So Dell has a tool for the, I can't remember all of it. It's OMSA, OMSA. I can't remember. It's like Open Managed Server or something. And it's kind of Dell's tool chain. It's open source. It's out there that lets you do diagnostics on Dell hardware. It's not quite working, but it's kind of out there as an example of just that use case of, I need a diagnostic image. I want to be able to build it. I want an intermediate that I can go out to. It's kind of an extension to the sledgehammer work. It just does more tools, and in some regards, more of our Dell-specific
Mojo
diagnostic tools, right? So anyway, it's kind of interesting. Along the debug lines, Victor's like typing furiously at me. We've updated some of the sledgehammer tools to kind of orthogonal to this discussion to allow for some debug modes, so that you can drop the node into debug mode to figure out what's going on that specific node. So there's been some changes in the area to help that better, but and just kind of interesting, we've looked at the idea of a diagnostic image out there as well. So.
I believe we're about to move to our last topic, which is putting us right on time. We are.